Okay, so in this video I'm going to talk through just the questions that were on the purple slide and the green slide on the Hess Law PowerPoint. The yellow slides have got the worked examples on, so you should be able to see the answers for those. The first question gives us a reaction, and it asks us to find the enthalpy change of that reaction. They've given us in the table some data on enthalpy change of formation, so we know the enthalpy of the formation of these different products. They must have been made from the elements that are within them, so we just write those at the bottom here. You don't need to balance these, it doesn't matter. As long as this equation is balanced, that's fine. Our arrows are going to be going up from those elements to the products because we're forming them from these elements at the bottom. We're then going to add in the numbers, so if you look on your table you can see what the enthalpy change of formation of these different things are. So we've got minus 2,984 for the formation of P4O10. The formation of H2O in the table is minus 286, but we're forming 6 of them, so we need to take that into account here. The same over here for the phosphoric acid. The table says minus 1,267, but we've got 4 of them. Okay. So now what I'm going to do is work out what this is equivalent to. This is what I'm trying to find, the enthalpy change of reaction. So I can't go from here to here directly, that's what I'm trying to find out. So instead I'm going to work my way this way around the cycle. Hess law tells me that this enthalpy change is equivalent to these enthalpy changes and then this enthalpy change. So the tricky part here is that we're going the wrong way along these arrows. These values are for the formation, but we're breaking them back up again essentially into their elements, the way that we're going around the table. So what we want is to reverse the signs of all of these. So I'm going the wrong way along this arrow, so I'm going to do minus 2,984, because it's going to be the opposite of the enthalpy change for the formation, and minus 6 times minus 286. Again, we're going the wrong way along the arrow. From here, I'm moving the correct way up this arrow in the direction that it's showing, so I'm going to add on these values here. Now when I put all of that into my calculator, it comes out as minus 368, and that's in kilojoules per mole. Okay, we're going to work on the next question now, which is on slide 10. And that question gives us combustion data. And they've given us the reaction for the formation of nonane over here, C9H20. And they're asking us to find that enthalpy change. You could label this delta HR, enthalpy change of reaction, but it's also the enthalpy change of formation because we're forming 1 mole of this product. Now this time, I want to find the enthalpy change of formation, and they've given me combustion data. So the part that I can add in now is the combustion of these substances to form carbon dioxide and water. Again, it doesn't matter if this part is balanced, as long as this part is balanced across the top. So now I add in my data from the table just like before. The enthalpy change of combustion of carbon is minus 394, but I've got 9 moles of carbon, so 9 times minus 394. Again, hydrogen has an enthalpy change of combustion of minus 286, but I've got 10 moles of it. And my nonane over here, I've just got 1 mole of, so I'm just taking the value from the table. So this is what I'm trying to find, remember, the enthalpy change of formation. And instead of going here to here, I'm going to go here to here, and then back up to my product. So my enthalpy change of formation is 9 times minus 394 plus 10 times minus 286. But then I'm going the incorrect way up this arrow. I'm not going in the direction it shows, I'm going in the opposite direction. So I need to change the sign. It's minus 6,125 in this direction, but it's plus 6,125 in this direction. If you can do the maths in your head, you could obviously just put the plus here instead of putting minus 6,125. It comes out the same. That gives us an enthalpy change of formation of minus 281 kilojoules per mole. Okay, moving on to those last two questions then. They were on the green slide right at the end. So we're looking at slide 11 now. There's two questions on there. We'll go through each one in turn. So the first one gives us the equation. And it's asking us to calculate the standard enthalpy of formation of methylbenzene over here. Now in the table, they must have given us values of enthalpy change of combustion. So we know that when we combust these things, we're going to form carbon dioxide and water, because carbon will oxidize to form carbon dioxide, hydrogen will oxidize to form water. Now what I need to do is add in my values from the table. The value for the combustion of carbon from the table is minus 394, but I have 7 moles of carbon. So 7 times minus 394. Hydrogen's value from the table is minus 286, but I have 4 moles of it, so 4 lots of 286. And the methylbenzene I've just got 1 mole of, and the enthalpy change of combustion of that is 3,909. So I'm trying to find this value here, delta HF. So instead of going from here to here, because that's what I'm trying to work out, I'm going to go this way around the cycle instead. So I'm going the correct way along both of these arrows. So I just leave those as they are in my cycle. But here I'm going the incorrect way along this arrow, so I need to change the sign. When I put that in my calculator, it comes out as plus 7 kilojoules per mole. Now remember, enthalpy changes are often about exothermic and endothermic reactions, or almost always, so it's really important that you include the sign, whether it's plus or minus at the end. Our final question, again on that green slide right at the end of the PowerPoint, hasn't given us an equation. They've asked us to work out the enthalpy change of combustion of propene. So I'm going to have to write an equation first before I can do that. So here's propene. And I know that the products of combustion will be water and carbon dioxide. Now I just need to balance that. Like so. Now the table has given me the enthalpy change of formation. So because I've been given formation data, I want to write the elements that these substances were made from at the bottom. And my arrows are going to be going up because I'm forming these substances. So if I look at my table, propene has an enthalpy change of formation of plus 20. The enthalpy change of oxygen, you'll notice, isn't included in the table, and that's because oxygen's an element. So by definition, its enthalpy change of formation is 0. There's no change between this and this. The enthalpy change of formation of carbon dioxide is minus 394. Again, I've got 3 moles of them, so I'm going to do 3 times minus 394. And finally over here, water has got an enthalpy change of formation of minus 242, but I'm forming 3 moles, so it's going to be 3 lots of minus 242. Okay, so when I'm working out my enthalpy change of combustion across the top here, I'm going this way around the cycle. So I'm going the wrong way along this arrow, so I need to change that sign. The 0 is irrelevant. Then I'm going the correct way along these 2 arrows to get back to these products over here. Like so. When I put this in my calculator, it comes out as minus 1,928 kilojoules per mole, and that's my final answer. Just one tip for when you're doing these in the exam. Make sure you draw this cycle and annotate it with the values. Even if you then make a mistake when you're doing the calculation, the correctly annotated cycle will gain you some marks.